Hello, class. I'm Dmitry Mendeleev, and I'm the very first creator of the periodic table. Although my version was just a very slight change from yours, because I arranged it according to atomic mass. Also, something I really struggled with as a scientist was leaving blank spaces in the table. I had to do this because, let me see, what does your textbook say? Because I had yet to study the physical and chemical properties of these elements.
Hello, third period ICP class. My name is Niles Bohr, and I, not to brag, proposed the atomic model that suggests electrons were in a fixed orbit around the nucleus, otherwise known as energy levels. The lowest energy level is called the ground state, while the highest energy level is called the excited state. The lower the level, the lower the energy, and the higher the level, of course, is the higher the energy.
Okay. Is it going? Oh, goodness. Well, excuse me, class. To start the lesson today, we are going to be learning about the three groups that all elements can be divided into. The first group is metals, which they tend to lose electrons to form a positive ion, which is a charged atom. They're often solids, and they're ductile, and what?
So what's the difference between an atom and an ion?
But first, my sweet, idiotic child, we have to divide elements into three groups known as metals, nonmetals, and metalloids.
Wait, so what's the importance of a valence electron?
So, to answer your question, my One Direction lover friend, valence electrons are the outermost electrons, and they're important because they determine the chemical reactivity. And you can tell what a valence electron is by electron dot diagrams, which I will demonstrate now. Well, since you asked, electron dot diagrams consist of dots in the element of your choice. For the first example, we will be doing neon. Since neon is in group 18, you're going to write the symbol. So, because it is completely full of, the energy level is completely full, you're going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. But if you were going to do an element such as oxygen that does not have a completely full shell, they're missing 2, so they'd have to gain 2 because it'd be easier to gain 2 versus losing 6. So with that, you have 1, 2, 3, 4, 5, 6 valence electrons in the outer shell.
I understand all that, but I don't understand what's the difference between the noble gases, halogens, alkali metals, and the alkaline earth metals. I mean, me and Fluffy want to know.
Oh, my cat-loving friend. The difference between these elemental families, for example, the noble gases, is the fact that in the noble gas family, they are group 18 with 8 valence electrons in their outer energy levels, and they are a stable family. There's nothing funky going on over there in that house. So they don't really combine easily with other metals. And the halogens, to differentiate between that, they're in group 17 and are called the halogens because, why the heck not? Alkali metals are, like, for example, fluoride, chlorine, bromine, and they each have only 1 valence electron, and the alkaline earth metals have 2.
So pretty much, class, all we learned today, which was super simple, what an energy level was, and what the function of an electron dot diagram was, who our teacher was, and we distinguished between noble gases, metals, nonmetals, and metalloids, on top of a bunch of definitions, and what noble gases, halogens, alkali metals, and alkaline earth metals are. I mean, it's really simple, guys, if you think about it. And teacher, can I put a sticker by my name?